Hello everyone. In today's video we'll learn about linear convolution. Convolution is a very important mathematical operation in digital signal processing, and there are two ways to do it. One is linear convolution and another is circular convolution. We'll see circular convolution in later videos. So in linear convolution we will be given an impulse sequence which is represented by h of n. Here, as you can see, the impulse response of a linear time invariant system is h of n, 1, 2, 1 and minus 1, and then we're asked to determine the response of the system to the input signal, which is xn. So here hn represents the impulse sequence, and xn represents the input sequence, and we are asked to find out what is the output yn will be after we convolute them. So as you can see, this star looking thing, this represents the convolution symbol. Okay, so we will be asked to find out the output after convoluting these two. Okay, so this little arrow actually represents the 0th position of the sequence, or the reference point of the sequence. So this is the 0th position, this is the -1 position, this is 1 position, this is 2nd position, etc. And similarly with this one. So first we have to find the number of elements in the output. The number of elements is very easy. So we have to add up the number of components in the impulse sequence, that is 1, 2, 3, 4, and the input sequence, that is also 1, 2, 3, 4 minus 1. So 4 plus 4 minus 1. This is basically a formula to find out the number of components in the output sequence. Number of components in the impulse sequence, that is 4. The number of components in the input sequence, that is also 4, and minus 1. You have to add minus 1 at the end. So this will give us, in this case, 7. So there will be 7 components in the output sequence. And from where the output sequence will start, this here, as you can see, that there is only 1 number on the left of this sequence and 0 number, that's no number in the left of this sequence. So in total, if you consider both of them, in total there is only 1 number on the left of the arrows. So as it represents left, we'll use -1, and on the right side of the arrow we can see 1, 2, 3, 4, 5. In total there are 5 elements on the right side of the sequences. So as it represents the right side, we'll use +5. So the range of the output sequences will be from -1 to +5. That means y of n will be starting from y of -1 to y of 0, y of 1, y of 2, 3, 4, and y of 5. Okay, so in total, as you can see, there are 1, 2, 3, 4, 5, 6, and 7 components. Okay, and now we'll find out how to calculate each of them. We'll start with y of 0. Basically, what you need to do is you just write the input sequence first. Here, as you can see, the input sequence, I'll just write it down: 1, 2, 3, 1. Then write the impulse sequence h of n. But remember one thing, you have to fold the impulse sequence before putting it here. How to fold it? This is very easy. See this 2 represents the 0th position, so whatever in the right side will go to the left side, and whatever in the left side will go to the right side. So this will look something like this. Always you have to use the folded version of the impulse sequence. Just keep that in mind. Okay, now as we have folded the impulse sequence, we'll just zero pad the whole thing. How to zero pad the whole thing? Remember that you always have to match the position of this arrowed component. Okay, so as you can see, there are no numbers in the left of this arrow, but there are two numbers in the left of this sequence arrow. So to compensate this one, I will add just 2 zeros. And as you can see, here are 3 numbers on the right side of this arrow and only 1 number on the right side of this arrow. So to make it 3 numbers, I will just add 2 more zeros. So this is how we zero pad the whole thing. And then what we'll have to do is we have to multiply the numbers and sum them up. Okay, this is very easy. For example, 0 times minus 1 equal to 0, plus 0 times 1 is again 0, then 1 times 2 is 2, then 2 times 1 is 2, then 3 times 0 is 0, plus 1 times 0 is 0. So that will give us the result of 4, sorry, y of negative 1. You have to do the same thing as before, only one change will be there. I'll just show you. The input sequence will be the same, you do not need to change it, but in the folded version of the impulse sequence you need to make one change, and that is, instead of putting the arrow where it used to be in the 0th position, now as you are finding out the value of y of negative 1, you have to put this arrow to the right side of where it used to be. So for negative numbers, you have to put the arrow to the right one position. It was, if you want to find out the positive of this y1, then what you have to do, you have to just put the arrow in the left side. That's it. That's the small change and nothing else. So again, you zero pad the whole thing. As you can see, 3 components on the left of this arrow, so I will just add 3 zeros for this one. 2, 3, 1, and minus 1, 1, 2, 1, and 3 components on the right of this, so 3 zeros goes there. Just make these 2 arrows in the same position. Then again multiply them and add them together, and as you can see, what we will get is 1 times 1 is 1, then 2 times 0 again, plus 3 times 0, plus 1 times 0. So we get the result, which is 1. So we have found out y1, y of negative 1. In the similar way, you have to find out the y of 1, y2, y3, y4, y5, and as you can see, it's a very tiresome work and it needs a lot of time in the exam hall. So if you want to make it quick, and there is another method that I'll show you, it is called tabular method because you just need a table. You just have to create a table. So you have to put the impulse sequence here and the input sequence here. Okay, now what is h of n? 1, 2, 1 and minus 1. So 1, 2, 1 and minus 1. That's it. And what is x of n? 1, 2, 3, 1. So here it goes, 1, 2, 3 and 1. That's it. Then make a table out of them. Then what you need to do is you have to multiply them with each of the boxes with their corresponding rows and column numbers. For example, 1 times 1 becomes 1, 2 times 1 becomes 2, 1 times 1 becomes 1, negative 1 and 1 becomes negative 1. 3 times 1 is 3. Similar way, you just fill the whole table. 1, 2, 1 minus 1. Okay, after the table is filled, then what you have to do is you will just add them up in this sequence. Okay, and in this sequence, what do you get? You will get this. This is simply 1, nothing else, so 1. And in this sequence you get 2 plus 2, that means 4. In this sequence you get 1 plus 4 plus 3, that means 8. In this sequence you get negative 1 plus 2 plus 6 plus 1, that means again 8. In this sequence you will get 3. In this sequence negative 3 plus 1, that means negative 2. And in this sequence negative 1. So that is the output sequence. And you might be wondering then, what is the 0th position of this output sequence? Remember that we have found out the range here. The range was from negative 1 to 5. So in this output, the range will be, this represents negative 1, this represents y of 0, this represents y of 1, this represents y of 2. Similar way, this represents y of 5. And that's how we can do linear convolution in a much more simpler and easier way in this tabular method. So that's it. If you have any question, please ask in the comment, and please like the video and subscribe the channel. I'll be posting more videos that contains engineering mathematical problem solving in the future, hopefully. So thank you.